Hi, this is Tasien. Welcome to today's presentation. Today I'm going to show you how to do a multiple linear regression model in R. I'm using R Markdown in R Studio. We are starting with loading libraries that we need in this presentation. We might need the tidyverse library for data manipulation, and we need the library ISLR2 to load the dataset that we are using in this presentation. So let's load these two libraries. Now that we have these two libraries loaded, we are ready to start our presentation. If you don't have these libraries installed on your computer, you have first to install those two packages before loading them. In today's presentation, I'm going to use a dataset from this library, the dataset under the name Boston. And maybe if you want to know more about this data, you can go to help and ask the R library, then a question mark followed by Boston will do so. Yeah, then the information will pop up here in help, and you can go ahead and read about this Boston dataset, and you will know what is contained in this dataset. Yeah, we are using this dataset, and we can try to view it to have a general overview of this dataset. Then take another junk here, and we can view this dataset. For instance, we can use the glimpse function, and Boston. Yes, this will show us what kind of dataset we have here. We have a dataset with 506 rows and 13 columns, and we have all these variables down here. Yes, yeah, yes. And another function that you can use to view more details is the still function. Then Boston, yeah, this still. Yes, yeah, that's the data set that we are going to use. To do a multiple linear regression, the function LM that we used in our last video, if you didn't see my last video about simple linear regression, you can go to my videos and search for the video whose title is Simple Linear Regression. We use the same function LM to perform a linear regression model with one predictor. But in this case here, we are going to use the same function but with multiple predictors, one response variable and multiple explanatory variables. So suppose that we are going to fit a model. Let me call it M, the model M, and this model should be a multiple linear regression model. We call the function LM, and the formula should have the response variable. Suppose that our response variable will be this variable median value of all occupied homes in US dollars. Then we type med here, med V, and the explanatory variables, let's say that the explanatory variables are the L stat, this variable, lower status of population, L stat, and this is one variable. If we want to add another variable to our model, we use the plus sign to add another variable. Let's say that we are adding the variable age, and if we want to add another variable, we have to use plus and add another variable, and so on. So let's use just two variables to demonstrate. Yeah, we also need to specify which data set we are using. Then the data, in this case, we are using the data set Boston, and our model is ready to be run. We have the response variable and we have two predictors. A multiple linear regression model with two predictors, two explanatory variables. So if we run this, we get our model here, and this model has different attributes that we can see in here. And to see the output of this model, we can just type M here and it will pop up, the output will pop out, and we will get the coefficients for our model. We have the intercept here, we have the coefficient for L start variable and the coefficient for the age variable. In this case, we have a model of the form med v equals this intercept and minus this coefficient here, this coefficient times this variable, and plus this coefficient times this variable age. Yeah, times. We have a model of this form. This is a multiple linear regression model with two predictors, L start and age, and the response variable being the med variable. Yeah. So the same way as we did for the simple linear regression model, we can extract the sum of outputs of this model, and we can also use the summary function to see more of the outputs of this model. Then summary of our model M, if we call the function summary and run it, we will get this kind of output. We have summary for residuals, minimum, maximum, median, and the quartiles, and we have t-test output for coefficients, and we have the coefficients values, the intercept, and these coefficients for each variables. And the second column has the standard error, the third column has the t-values, and the last column is the p-values. And from the output also we can read the residual standard error and the r squared coefficient, the adjusted r squared, and we can also read the p-value, overall p-value of the model. Yeah, so we have many things to read from the model. And for instance, if we want to only extract the coefficients from this model, we can, let me add another chunk here. Suppose that we want to extract the coefficients, it's just calling the summary our model, and use the dollar sign and just write coef. You can write coefficients or just coef like this, then you will get the coefficients here. Yeah. And if you want to extract, for instance, the coefficient of determination, is the same way you use the summary function and summary of our model, and followed by the dollar sign and r dot squared. You can write quad squared and you get your coefficient of determination here, or you can just write r dot square sq, then it will give the same result. If this is the coefficient of determination, the same number that you can read from here. You see this one, this coefficient of determination. Or if you want the adjusted value, I mean this one, you can now, instead of using r dot square here, you use adjust dot r dot square. Then you will get this value, which is the same here. So we have our multiple linear regression model with two predictors in the model. But as you have seen, this Boston data set has more than two variables that can be used to predict this made variable. It has 13 variables here, all these variables here, 13 columns. We have 13 variables, and we can use all the 12 variables to predict, for example, the made variable. But if we use the same way here, using the plus sign to add each variable, it may take it's a bit much demanding to just write all the variables up to 12 variables. But fortunately, there is a short way to do this. How do we do this? Just with one point and do that. How do we do it? Let me create another model and show you a short way to do it. Let me call the model M1, and M1, we need a multiple linear regression model for the made v as a response variable, and the explanatory variable should be all the remaining variables in Boston dataset. Then to do so, we only add a point here, and this point will say that we use all the remaining variables in our dataset, and the dataset that we are using is the Boston dataset. So the response variable is the made v, and the predictors are all the remaining variables in the Boston dataset. That's the point. Only this point will do that. Let's see. We have the model and then the summary of our model M. If we run it, what do we get? We get this, and as you can see, now we have all the variables listed here. All the variables listed here and their corresponding coefficients. In just one command, the dot point can do that, and we get all these variables. If you can see these results, if we read this last column for the p-value, for instance, this variable h has a very high p-value of 0.78, which is very much, and it is the indicator that this variable is not good to be included in our model. So for instance, if we want to exclude this variable from our model and leave other variables in the model, how can we do it? There is two ways to do so with using the whole data set. One way is is to use minus sign and followed with the variable age in this formula here. In our formula here, we can add minus sign is followed by the age variable, then that one will remove the variable age. Let's see that. Let me copy, oops. Let me copy this one and create another model. We need to create another model which doesn't have the variable age. Yes, let me call it M2. And what do we do is just to remove one variable age to our model. Just use the sign minus for the variable that you want to remove, in this case the variable age. If we run this model, what do we get? We get M and the summary, and the summary will give us summary M2. It will give us this, and the results, if you see the results here, it doesn't have the variable age. We have already removed it. Yeah, and we can keep removing variables in that way. For instance, you can remove also this one. You see they have, yeah, and to remove this variable in the source is, you can do it the same way as I have done up here. So this one way to remove this, and another way, instead of removing this variable age like this, you can use also the update function. What do you have to update? You have to update our model, the first model that we have created. And how do we update it? We can use the update function like this. Let me create another model. I call it M3, and then I update. What do I update? I update our model M2, and M2, and what, how do I want to update it? I want to keep all the variables except the variable age, and we are using the same data set, and the data set that we are using is Boston. Yeah, yes. So then our M3 model, if we summarize it, summary M3, and what do we get? We get the same result as above. We get a model without the age variable. We have already removed it. So far, I have already shown you how to create a multiple linear regression model without interaction terms. So, how can we add interaction terms in our model that we have just created? If we want to create a model with interaction term, let's for instance start with our first model that I have created, the very first model here, this model, the model M. And for this model we have two variables, two predictors, L start and the age. So suppose that we want to add the interaction term between these two, L start and age, these two variables. How do we add interaction terms? Let me copy this and paste it down there, and paste it here. Yeah, so how do we add the interaction term? To add the interaction term here, you just use a plus sign and then use L start, this first variable followed by two dots and age after. So this command here will add the interaction term. if we run this model, let me call it M5, model with interaction terms. Yes, model with interaction terms. Yeah, model with interaction terms. I call it M5, yes. Then if we take the summary of our model, summary M5, we will get this output here, and the output will have four coefficients: the intercept coefficient, the coefficient for the L start variable, the coefficient for edge variable, and the coefficient for the interaction term between the L start variable and the edge variable. Yeah. And maybe I can also show you a very short way to do the same model here without writing all these ones. There is one command that can be used, and that command is like a start. If we take a start followed by a star sign and the H, and replace it here, replace it with all these predictors here, we will get the same result as above here. Let's do so and see. Let me call it M6 model, then LM med V, and then we take L start times H, and the data set is the same data set. It's the Boston data set. What do we get here? We get this model and the M6. If we compute the summary for our model, what do we get? We will get the same four coefficients. And see, we have the same four coefficients as above. Yeah. So that's how we can include the interaction terms in our model. And sometimes we may also need to include quadratic terms in a model, depending on how the data we want to model looks like. How do we add the quadratic terms? For instance, suppose that I create another model M7, and suppose that we want to model the med V variable with which variables, with predictors, with a predictor L start and its quadratic term. How do we include the quadratic term for this L start variable? We do that by adding this, by adding I. In parentheses, we add our variable L start to power 2. And the data set being the same data set. Our data set is the Boston data set. So this model will give us a model with this variable and its quadratic term. We have a model with 3 coefficients. Let's see the summary. The summary of M7. We have a model with 3 coefficients: the intercept term, and the coefficient for L start, and the coefficient for the quadratic term, L start squared. Yeah, so guys, that's how we can create multiple linear regression model in R. I hope you have learned a lot from this today's presentation, and you can be able to create a multiple linear regression model in R either without interaction terms or with the interaction terms, and and with quadratic terms. Yeah, I am happy to have you here, and I hope you have enjoyed today's presentation. Please don't forget to like the video, share to your network, and if you did not subscribe to this channel, make sure to subscribe. And I hope to see you for next time. Bye.